Welcome back to True North Mechatronics. With our ultrasonic bracket locked in, we need to solve a problem affecting the inexpensive IR sensors we're using for our bottom-mounted line following array. These modules utilize a 5mm LED format lens where the wire leads are simply bent around the edge of the circuit board. In robotics, hanging mass is a liability. Every bump this chassis takes wiggles those exposed leads. Over time, that vibration causes metal fatigue and eventually connection failure. So the solution to this problem is an open box shield that captures 80% of the lens length, physically constraining the bulbs and eliminating that mechanical strain. Design, engineer, deploy. Let's get to the CAD. Begin by creating a new body and a new sketch on the XY plane. We're going to grab the rectangle tool and we're going to create a rectangle that follows the y-axis. We're also going to make this rectangle symmetric with respect to the origin. And we're going to set the length of the left-hand side here to 59.5. And we're going to set the top dimension to 18.5 millimeters. And we're going to add a fillet to these two corners here. And I'm going to grab this first fillet and the second fillet, and I'm going to set them equal to each other. And now I'm going to set the radius of this top fillet to 7 millimeters. Now, approximately here underneath the mobility base is a screw that holds on the accessory deck. So, in order to clear a pocket for that, we're going to grab the tool to create arc by 3 points. I'm going to click on either side of the y-axis. I'll put the arc about right there. And I'm going to constrain the center of this arc so that it is in line with the end of the arc itself. And now the next step here is I'm going to use the snip tool and I'm going to snip away the center section of that line. Alright, so we're going to make this arc so that it's symmetric around the x-axis. And now that we've done that, we can set the radius of this arc. So let's set this radius to 8.5 millimeters. All right, so with that, we have to constrain this line. It's missing its vertical constraint, so we're going to constrain this one vertically. And now that we've done that, our shape is fully constrained, so we can close out of the Sketcher workbench. And we're going to pad this shape out to 3 millimeters. And we're going to add the pockets in this shape that will accommodate the two mounting screws. These are going to be the same screws that are used for attaching the ultrasonic sensor bracket to the mobility base. So we're going to hold two parts to the mobility base at the same time with the same two screws. So let's left click on this top face and create a new sketch. We're going to grab the rectangle tool and we're going to create two rectangles here. Make sure you don't click on the y-axis because otherwise you will constrain symmetric with that y-axis. Let's set the vertical dimension of both of those so they're the same, as well as the horizontal dimension. And now let's size them. So let's set the the vertical length to 14.5 millimeters. Now we'll set the horizontal to 7.5 millimeters. Okay, so that's them constrained in size. Now we're going to make them so that they're collinear, but we're also going to make them symmetric across the x-axis, so we can do two things at once using the symmetry tool. So now they move as a unit. We're going to set the distance between them now. So let's create a separation distance for these two pockets of 24.5 millimeters. And now we're going to set the location along the x-axis. We're going to do that with reference to this left-hand edge here. So using the external geometry tool, we'll reference that left edge. And we'll create an offset there of 3 millimeters. So let's bring that out. There we are. We'll do it there. 3 millimeters. All right. So now we've constrained the pockets. These are going to be the open boxes that make it so that the LED lenses for our infrared sensors can move and wiggle about. And then we need to add the two mounting holes here. These are going to be the same dimensions and setup as what we used for attaching the ultrasonic sensor. Let's make this symmetric around the x-axis. We'll make both of the diameters the same. And for this one, I think we'll just use 2.8. That way our screw will bite into this part and the other part. It'll keep us from perhaps stripping out the plastic holes while we're trying to do up the screw. So, and we're going to set the separation distance between these two parts now. So let's set that distance to 36 millimeters. And that leaves 1 degree of freedom, and that degree of freedom is going to be the position along the x-axis. So let's reference the front end of our guard here, and we will take and create an offset distance for this of 4 millimeters. All right, so with that, we have now fully constrained all of the pockets that we want to add to the guard. And we can close out of the Sketcher workbench, and we're just going to pocket those through, accepting the default of 5. All right, so now we need to bring up the level of the box for containing those LED bulbs. So let's create a new sketch in the top here, and we're going to reference the top and bottom edges of our shape. And let's grab the rectangle tool, and we're just going to drag out a box on each one of them. We'll constrain them into place here in a minute. Let's take and constrain them right to the very edge of our line segment. So let's do that for top and bottom. All right, so now that we've got that done, we also need to constrain the overall length of these. So I'd say let's reference this edge right here. Let's make this edge of the box coincident with that one, and we can solve this problem by making that shape symmetric across the x-axis. Okay, so the two sides of our boxes now, we will extrude those, but we also need to include the cutout here. So let's use our external geometry tool. Let's reference the inside, top and bottom edges of both of our pockets there. And using the rectangle tool, we will bring in those pockets. All right, so that shape is fully constrained. We can close out now, and we're going to pad this shape out to 5 millimeters. And with that, we have created a relatively useful guard to protect our infrared sensors, LED bulbs from jiggling around and breaking due to metal fatigue. In the next video, we're moving to the absolute front of the Sparkbot to engineer the scoop. While this scoop or plow is ostensibly designed to get under our opponents in the SumoBot ring, it serves a secondary critical kinematic purpose. It's the forward stabilizer. When we designed the chassis pitch spacer back in part number 5 to lock in our ride height, I actually calculated that geometry with the prototype scoop already installed. So this allowed me to set a precise 1 millimeter clearance between the bottom of the scoop and the driving surface. So this means that if our differential drive robot tries to come to a quick halt, then that would have potentially caused the battery on the top of the robot to pitch the robot forward on its face. But by having this scoop there with a 1 millimeter of distance above the travel surface, this will arrest any forward pitching movement of the robot. So, chart your course, build your world. I'll see you in the next one.